Hi, kiddos. This is 2.4 Creating and Solving Inequalities. Essential question: how do you write, and solve an inequality that represents a real world situation? Now, an inequality often is in reference to a situation in life. For example, you would rather have $10, right? Because 10 is greater than $5, right? So that's where inequalities really start to have their purpose. Okay, is that idea right there? Something's better or bigger or smaller than something else. So our shortest answer is basically we use a verbal or tabular model to write an inequality. Then we solve the inequality and then check for reasonableness. So reasonableness is in context, real world situation. So we're going to learn how to write, solve, and then check for reasonableness. So that's like the main things you have to know how to do. All right. So let's look at some examples and get going. Creating inequalities from verbal description. So an inequality is a statement that compares two expressions that are not strictly equal by using one of the following inequality signals. So the first one is less than. All right. So that's this symbol right here. So that's the first one. Less than. So, for example, 5 is less than 10. All right. That could be one way of saying it. The second one is less than or equal to. For example, 10 is less than or equal to 10. Now, is it less than? No, but is equal? Yes. So part of that is true. Now, 3, greater than. 10 is greater than 5. So that's another way we can say that. 4. So the next one is greater than or equal to. So 11 is definitely greater than 10. What if it was 11? So would this statement be true? Greater than or equal? Well, it's or, so yes, it's equal, right? So notice how that stays there. Not equal. 10 is not equal 5. So that's the fifth one. All right. So example one, Nora is planning a birthday party for her little sister. That's adorable. Nora's budget will allow her to spend no more. Okay, no more. So that's a big important word right there. No more than $50 for party supplies. There's 8 kiddos. Okay, so I'm thinking quantitatively. There's 8 kiddos, including Colleen, will attend the party, and Nora wants to determine how much she could spend on party favors for each child. She also wants to purchase a cake for $10. All right, so we have a situation where we have 8 kiddos, right? So 8 children. I'm using C for children. Okay. Um, and $10 for cake. Okay, so I'm thinking initial value. And no more. What does no more mean in a sense of inequalities? Can she spend more than? No. Can she spend less than? Yes. Can she spend exactly $50 and still be okay? Yeah, because as long as it's no more. So it's going to be less than she can spend or exactly $50. So that's where inequalities can come in. All right. She wants to be below or just at $50. So that's why we use the less than or equal symbol. All right. For this situation. All right. So we just wrote the inequality. That was the first thing they want us to do. Um, and then find the possible solution. So let's figure out how much she could spend per kid. Well, first things first, let's isolate the variable. So let's get rid of that plus 10, right? Subtraction property of equality cancels out. We got 8 children still, less than or equal to 550 minus 10, which is 40. And then how to get rid of a multiplying 5 or 8, divide. And what you do to one side, do to the other. Again, that is the division property of equality. So children less than or equal to 5. 5 what? We're talking about money. So we're talking about less than or equal to $5. So Colleen, or Nora, sorry, Nora is the one who's doing the planning here. Nora may spend uh, up to $5 per per what is it called again? Party favors. Party favors for kids. Party favor. So could she spend, $4 per kid? Yeah, she could totally do that. Could she spend $3? Sure. Could she, and then the max is, of course, $5. So that's the idea of inequalities. All right. All right, so creating and solving inequalities involving the distributive property. So again, the distributive property oftentimes comes with the parentheses. And what it really means is that, for example, this A is really multiplying to that B and multiplying to that C. B and C are really multiplying to A. So notice how you could say it the other way. So we're going to use that in these situations. So for example, Trina, she's buying 12 shirts for the drama club. She will choose a style for the blank shirts and then pay an additional charge of $2.75 for each shirt. So she's spending 12 bucks, right, per shirt plus an additional $2.75. So we got shirts, that's an S, plus $2 per and 75 cents for each shirt, right? All right, cool. So that's what's happening there. If Trina cannot spend more, notice how it says cannot spend more. So can she be more than how much money she wants per shirt? No, that's not possible. So she wants to not be more than. So we're going to say less than. So this S is the shirts. She wants to be less than a certain amount, which is $99. So less than $99. She wants to be below that. Okay, she cannot spend more than 99. How much can she spend on a blank shirt? Okay, so let's go ahead and apply again the distributive property. This 12 is multiplying to that S and to that $2.75. And let's see, a quarter of 12 is 4, and 2 times 12 is 24. 24 plus 4 is 28. Let me grab my trusty calculator and make sure I'm not leading you down astray. It is a Sunday, so I am trying to make sure I don't mess up here. Oh, yeah, I totally messed up. Wow. Oh, I see what I did. All right, 0.75. So that's not 28. Good thing I checked. I felt weird about that one. It's actually 33. So what Mr. Webb did on accident was I multiplied by 0.25 in my head and said 4. In reality, it's 8 plus the 24, which gives me 33. There we go. All right, so again, she's still trying to spend less than. All right, how do you get rid of a plus 33? So again, this was the distributive property. That's how we were able to multiply everything by 12, right? And then how do you get rid of a plus 33? Because again, we're trying to isolate the variable, which is S for shirts, with the good old-fashioned subtraction property, right? All right, so now we have 12S is less than 66. And then again, how do you get rid of a multiplying 12? Division, right? What you do to one side, do to the other. So again, that's division property. All right, so that'll get us over here. So S for the shirts is going to be less than 5.5. So find out the possible cost of each blank shirt. So basically what's going on here is the shirts can be less than $5.50. No more than that. So that would be the answer. So she could spend, Trina may spend less than $5.50 per shirt. And then that'll keep her in her budget, which again, her budget was no more than $99. Okay, so your turn number one. Zach is planning to send a video game to each of his two brothers. Okay, so I'm thinking two brothers. If he buys the same game for both of his brothers and pays $4.75 to ship each game, all right, so we got some games plus the $4.75 being added on to each game. How much can he spend on each game without spending more than $100? So does he want to spend more than $100? No. He wants to spend less than, right? Without. That's a negative, right? So without spending more than $100. So he's definitely wanting to be below that threshold. So go ahead, use a distributive property, see how much he could spend for a game for his bros. All right, example 4 and 5. So solve each inequality. Now, we could use the distributive property and multiply this 4/3 to the x coefficient and to the 9 term. But we are trying to isolate the variable, which is already inside the parentheses. So how can we get rid of the 4/3? Who doesn't want to work with fractions? So we can actually multiply both sides if you want. Um, Basically to get rid of the 4/3. Now, 4/3 is really multiply by 4, divide by 3. What's the opposite of multiplying by 4? Dividing, right? What's the opposite of dividing by 3? Multiply by 3. So I'm going to go ahead and use the distributive property to get rid of that whole fraction in the front, that leading fraction. But remember, what you do to one side, do the other. So I'm not going to go ahead and distribute and deal with all these fractions. I'm going to go ahead and distribute to get rid of fractions, make this nicer. So 3 divided by 3 is 1, 4 divided by 4 is 1, and that will get rid of our 4/3 on the left-hand side. Now 3 times 4, right? 3 times 4 is 12. 12 divided by 4, right? So that's going to give me 3. So we have 6x plus 9 is less than 3. So let's go ahead, and again, that was the distributive property. And how do you get rid of a plus 9? Hopefully you're thinking subtraction, right? So that's a subtraction property of equality. All right, so we got 6x is less than negative 6. How to get rid of a multiplying 6, the coefficient in front of x, right? Hopefully you thought division. And that should give you negative 1. So again, that was the division property that got us through there. All right, so that will be our solution for this inequality. So basically our answer is anything less than negative 1. All right, so looking at the next example, you could distribute, okay, the negative 2 to both terms. Negative 2 times, 1/4 would give you this. You could reduce. Then it would give you negative 4 over here because, again, negative 2 times positive 2. And, again, reduce. Now, the reason I'm writing it up here is because, well, you could go this route. Okay, you could do it this way. Or, well, what's the opposite of multiplying by negative 2? Divide by negative 2, right? So I'm going to go ahead and try it this way. Just remember, what you do to one side, do the other. So let me get that. We get that. We get this. But newsflash, when you divide by a negative, what's interesting is the symbol actually changes. It actually goes the other way. Now, the reason why is because now we're changing our statement. For example, $10 is greater than 5, right? $5, right? But now it's like owing you $10, right, is definitely worse than owing you $5. So would you rather owe me $5 or $10? You would rather owe me $5. So notice how the symbol flips when the negation happens to both left hand and right hand side. And that's exactly what happened when we divided by this -2 to both sides. So the symbol actually flips to less than or equal. All right, so we got 5, -5 halves. Okay, so let's get rid of the +2, which is minus. So we subtract 2 to both sides. These cancel out. You get 1/4 x, which is less than 2. I'm going to go ahead and rewrite -2 as -4 over 2, because isn't that -2? Yeah, those are the same. This is that. Now, the reason I did that is because I'm combining it with this -5 halves. So I need a common denominator. That's why I did that. Okay. So you got 1/4 x is less than or equal to, what's -5 minus a 4? What's 5 plus 4? 9, but both of them are negative. So -9, and then again, half. What's the opposite of dividing by 4? Sorry, I forgot the variable. Multiply by 4. Just remember what you do to one side, do the other. So we got x is less than or equal to -36, all divided by 2. And that should give us a nice, pretty number of 18, -18. So x is definitely less than or equal to -18. Now, that was one way of doing it. If you continued on this way, addition property, you would have gotten this. Now, again, how do you get rid of a multiplying -1/2? Well, what's the opposite of dividing by -2? Multiplying by -2. Just remember what you do to one side, do the other, right? And that will take you here. Again, we're multiplying both sides by negative, so the symbol does still switch. And you still get the same answer. So take a while to study that. There's two different ways of doing this. So this is like way 1, okay, and this is down here. That's way 2. So just be aware. One might be easier than the other. It really depends on you. Just remember the properties of equality still apply like normal. All right, so your turn number 2 and 3. Go ahead, make sure you distribute, combine like terms, and then properties of equality. And remember, if you divide by a negative, the symbol will flip. All right. All right, so creating and solving inequalities with variables on both sides. So this is what we use to compare in real life. So we have two different companies. The People's Paper. Sorry, I sound like Ben when I saw that. All right, so Daily Info charges a fee of $650, ouch, plus $80 per week to run a ad. Okay, so A for ad, I guess. And the People's charges 145 per week. Oh, I guess we're going by weeks then, so not ads. Weeks. So I guess our variable won't be A, it will be W for weeks. Now the real question is, how many weeks must an ad run for the total cost of daily info to be less expensive than the People's Paper? Oh, okay. So let's see. We got daily info, right? And they're asking, well, when is this going to happen where daily info is less expensive than the People's Paper? That's a really good question. Let's find out. So daily info again was what? 80 bucks per week plus the 650. All right, and we're still asking ourselves less than People's Paper, which was just $145 per week. Yes, we don't have a charge fee of 650. We're cheaper. Well, let's find out how long that's true. So again, let's figure out combine like terms. So let's go ahead and get the ADW over here. Okay, that's subtraction property. So we got 650 is less than 145 minus 80. What is that? 65. Pretty sure. Yeah, 65. So 65 weeks. How to get rid of a multiplying 65? Divide, right? Division property. And it looks like that's a 10. 650 divided by 65. Pretty sure that's 10. All right, so symmetric property. So again, first off, we did subtraction property, right, to get the variables together. And then we used the division property to take care of the 65 for our coefficient. And then now we're going to use symmetric property to say weeks is greater than 10. So notice I changed my statement. That's called the symmetric property. All right, so basically what we're saying here is weeks, the number of weeks, it's going to take more than 10 weeks until, was it daily info is cheaper or costs less than the People's Paper. All right, so I'll stop with the Bane joke there. All right, so again, inequalities show us that situation. It's no longer when are they going to be equal, but in this situation, when is it going to be cheaper than this guy? All right. All right, so example 7, we got home cleaning companies. Looks like we're comparing this guy and Power Clean. All right, so let's see. Home cleaning company charges $312 just to power wash the siding of a house, plus $12 for each window. Looks like we're working with W again. So, okay. So I'm thinking home cleaning company as this. I'm thinking $312, right? Plus the $12 per window. So that's what I'm thinking of. Home cleaning company. Now, Power Clean is $36 per window. That's a little bit more expensive. Um, and the price includes power wash for the siding. So basically, they don't charge for the power wash on the siding of a house. So for Power Clean, I'm thinking not about weights. I'm thinking $36 per window. All right, now what are they asking? How many windows must a house have to make the total cost from the home cleaning company less expensive than Power Clean? All right, so notice what I did there. I said, I saw less than. So they're saying um, we got house or home cleaning company, all right, being less than um, Power Clean company, right? Power Clean. All right, so that's basically the question. Like, when is that going to happen? So, home cleaning company, we already had what, $12 per window plus the $312, right? Power Clean, on the other hand, again, it's less than. Power Clean is $36 per week. All right, let's try to figure this out. So, subtraction property, right? Let's find the difference in our rate of change. It's basically what we're doing. So that's subtraction property again of equality. And that's what, 24? All right. Symbol stays the same because we didn't divide or multiply both sides by negative. That's 312 still all by itself. How do you get rid of a multiplying 24? Divide, right? Just what you do to one side, do the other. Let me grab my calculator because I'm a little out of it right now. 312 divided by 24. 13. So we got 13. 13 what? We're talking about windows, right? So symmetric property, right? So we use division property up here to get rid of a multiplying 24, right? The coefficient for that variable. And then the symmetric property was applied here so that we can flip it around. So what does that mean in context, right? In context, this means that when you clean, or actually when you have more than 13 windows, uh, home cleaning company will be cheaper. All right, so that's the answer in context, and that's where inequalities help out. Your turn number 4, very similar type of question. Not only write the expressions for this, but again, see what they're asking for. How many pizzas the band members will have to sell to make a profit. So that's probably going to be involving more than what they sold. So let's see. The school supplier, the supplier charges $10 plus $4 per pizza. The band wants to sell the pizzas for $7 each. All right. Write and solve an inequality to find out how many pizzas the band member will have to sell to make a profit. So $4 per pizza, right? Plus $100 and $7 each. Make a profit. So I'll tell you what, try to figure out how to set this up. What symbols do you use? And just try to figure out um, how many pizzas they need to sell to make a profit. Sell the pizzas for $7 each. $7 each. Right? That's what I'm thinking. But now the question is they got to make more than what these guys are charging, right? So which way does your symbol need to go? Does it need to go this way, or does it need to go this way? Think about it. They need to make a profit. So which symbol do you use? Do you use greater than or less than? Greater than or equal? We're talking about profits, so probably not going to be equal, right? It's got to be greater. So I kind of just said what symbol to use, but you guys figure out what symbol. I don't want to give you too much of this. I already kind of gave you a lot. All right, so good luck on that one. There's your homework, page 77, numbers 1 through 9, 21, and 23. If you guys have any questions, feel free to see me on that. That's about it. And this is why not everything should be equal, by the way. I mean, look at those guys. They're doing the exact same thing, exact equal movement, and it just does not work out in the end. All right, have a good day.